So you've made the big decision, Kubernetes. You picked the platform, the sort of uh, operating system for the modern cloud. But here's the thing our sources point out right away. Choosing K8s. That's actually the easy bit. The
Yeah.
real decision, the immediate headache, is figuring out how you're going to install it. Because, well, the method really depends on what you're actually trying to do.
Exactly. I mean, you're looking at a platform that could just be running a quick test on a developer's laptop, right?
Right.
Or it could be managing the entire global setup for a massive company. The deployment needs worlds apart. And that's what we're digging into today, that huge gap between, say, a simple testbed install and the major effort needed for real production workloads at enterprise scale. It's like comparing pitching a tent to building a skyscraper.
Okay, let's really get into that difference then. Because if you're just messing around, testing things out,
Yeah, it's pretty straightforward.
you download it from the upstream repos, maybe onto a couple of servers, physical or virtual, and boom, you're basically running Kubernetes. Low friction.
Right. But that ease, it turns into, let's call it organizational debt, the second you aim for production. Running K8s, seriously, at scale, it demands significant strategic planning. You're not just installing software anymore, you're adopting a whole new way of operating. Our sources lay out these 5 critical things, 5 absolute must-have an enterprise has to weigh up when picking an installation approach.
And these aren't just nice-to-have features, are they? They're tied to major business risks. Let's start with the first one, high availability, HA.
Oh, HA is absolutely fundamental, mandatory.
Yeah.
The solution must guarantee highly available clusters. And crucially, this includes protecting the metadata store, where all the cluster state and configuration lives.
Yeah.
If that store, et cetera, goes down, well, it's not just downtime. You lose the entire state of everything. That's a catastrophic failure for the business, way beyond just the service blip.
And adding to that pressure, you've got the speed of the Kubernetes community itself. You mentioned upgrades.
Yeah, the upgrade cadence is relentless.
Yeah.
A major version rolls out every 3 to 4 months. It's a constant drumbeat of change you have to keep up with.
So how does an enterprise even deal with that?
Well, they have to absorb it strategically. They need to figure out what downtime is acceptable, for every upgrade cycle. Think about the resources involved. Testing, patching, deploying, validating across complex infrastructure every single quarter, just to stay current. That operational reality heavily influences how you choose to install and manage it.
Okay, and then there's the reality of modern business. Your infrastructure isn't usually just in one place. You need hybrid support.
Absolutely critical for consistency, right? Does the solution handle your private data centers and the public clouds you rely on? And maybe even more importantly, does it offer the same or at least a similar SLA and feature set across both? Because inconsistencies there, that's what usually kills hybrid cloud strategies. Dead in the water.
And once you've got hybrid working, the next step seems to be federation support, tying multiple clusters together across different clouds.
Yeah, federation sounds great on paper. Dynamic bursting, better resilience by spreading things out. But let's be real. While it's powerful, federation is notoriously difficult to get right, especially across different cloud providers. So the installation solution needs to somehow make that manageable, abstract the complexity, but still give you the control you need. Tricky balance.
Right. And finally, we get down to the nitty-gritty, what the sources call enterprise readiness features. This sounds like the day-to-day operational stuff.
Exactly. It's not just about running containers. It's about managing the people using the system. Governance becomes huge. You absolutely need things like single sign-on, makes user management way easier, and especially role-based access control, RBAC. RBAC is totally non-negotiable. You've got to ensure developers from Team A can only touch their stuff and definitely can't mess with sensitive things managed by Team B. Plus, you need things like persistent storage options, isolated networking, keeping everything properly segmented and secure.
Okay, so that's the enterprise picture. Sounds complex, high stakes, a whole platform just to run the platform. Let's completely switch gears then. How does the average developer who doesn't have months for planning even get started with Kubernetes?
Ah, right. That's where the all-in-one installation models shine. They're built for convenience, not for permanence. Perfect for, like, a local sandbox, testing things out, learning, exploring. They're isolated, self-contained, and quick.
But they have that big limitation, don't they? They're sort of the polar opposite of the enterprise approach.
Exactly. You can't share them easily, and they definitely don't scale for production loads. They're temporary environments, meant to give you a quick taste.
And the one most people probably hear about first is Minikube.
Yeah, Minikube is often the first touch point. It gives you a fully working single node Kubernetes cluster, runs locally. Usually it's inside a virtual machine right there on your laptop or desktop. It's a fantastic learning tool because it's just so accessible. Supports Macs, Linux, Windows, works with common hypervisors like VirtualBox, VMware, whatever you're using. It basically hides all that networking and HA complexities so you can just focus on deploying your app.
Okay. And the other main sandbox approach,
Yeah.
installing Kubernetes using containers.
Right. This one uses Docker Strength, packaging software easily. Instead of installing Kubernetes bits directly onto your machine, you run Kubernetes itself as a set of Docker containers, all running on a single host. Could be your laptop, a VM, a spare server. It's super clean because all the Kubernetes stuff stays inside those containers, doesn't mess with your main system. It's like an almost instant way to get a functional cluster going.
This is where it gets really interesting, I think, because even when K8s is running small, like in those containers on one machine, you can still see the whole architecture, right? The core pieces are all there doing their jobs. We can actually look inside this mini deployment and see the fundamental components that make Kubernetes, well, Kubernetes. Doesn't matter if it's a one machine or 1,000.
Exactly. It's a perfect way to understand the core concepts. We can see the four main components of the masternode's brain, all just running as separate containers in this setup.
Okay, let's break them down. First up, the cluster's memory, etc.
Right, etc. Think of it as the central database, the single source of truth. It stores all the configuration data, the desired state of everything in the cluster. The API server talks to it using simple APIs. If you lose, etc., the cluster basically gets amnesia. It forgets what it's supposed to be doing. That's why protecting this data, HA4, etc., was the very first enterprise requirement we talked about. It's that critical.
Got it. Next, the main control point, the gatekeeper, the API server.
The API server, yeah, it's the central hub. It's the only component that should directly talk to, etc. It handles all the communication internal between components and external requests from users or tools. If you want to deploy something, you talk to the API server. If components need to check status, they ask the API server. It's kind of like the front desk in the security guard for the whole Kubernetes master logic.
Okay. Third, the one that makes sure things actually happen as planned, the controller manager.
The controller manager. Its job is to constantly watch, etc., to see what the state should be, and then it watches the actual cluster, what the state is. It's always trying to reconcile the two, making reality match the plan. So if you said you wanted 5 copies of your app running and one crashes.
The controller manager sees that mismatch.
Exactly. It sees there are only 4, but the desired state is 5. So it automatically starts a new one to get back to 5. It handles all that scaling logic up or down to keep things matching what you asked for.
Makes sense. And finally, the one that decides where stuff goes, the scheduler.
The scheduler. Its whole purpose is deciding which node is the best fit for a new container, or a pod in K8's terms. It looks at resource needs, any constraints you've set, policies, and figures out the optimal place to run the workload. What's really cool is that even in that single host container setup we talked about,
Where there's only one place to schedule things.
right, even then, the scheduler still runs, it still performs all its complex decision-making logic. It just happens that the only valid answer is, put it on this local host. It really shows how that core Kubernetes brain is always there, even in the tiniest sandbox.
Okay, so wrapping this up, we've seen these two very different approaches.
Yeah, 2 ends of the spectrum, really. On one side, you've got the super convenient developer sandbox, great for learning, quick tests. On the other, you have the high-stakes enterprise setup demanding really strong governance, HA, RBAC, complex hybrid stuff. Both are totally valid ways to install Kubernetes, but they're solving completely different problems, meeting different strategic needs.
So the big takeaway for anyone listening seems to be, it's not just about getting Kubernetes installed. That's step one. The real challenge is making sure your installation strategy perfectly matches what you actually need to do with it. Trying to run your critical production stuff on like a Minikube setup, that's just asking for trouble, isn't it?
Oh, absolutely. Guaranteed failure. And maybe let's circle back to where we started. That relentless pace of change. Remember the major upgrade every 3 to 4 months? That forces constant attention, constant adaptation. So thinking about that, maybe the real deep dive question for any organization isn't just how they install K8s the first time, but how do they build that continuous rapid upgrade cycle into their actual long-term strategy? I mean, if keeping the platform stable and secure means constantly adapting, is that continuous adaptation now the most critical enterprise readiness feature of them all? Something to think about.